Good afternoon. This is Dr. Mahmoud Al-Odeh, and I'm here to explain for you the z-score and the area under the curve. So hopefully using this example, we will be explaining the idea of how to calculate the z-score and the area under the curve. We'll switch between different resources. So first resource, we're going to take the question, the example. A normal distribution has a mean of 5 and a standard deviation of 2. What proportion of the distribution above 3? In order to answer this question, what we need to do, follow the steps that I explained it in my earlier video. What you need to do first is to draw your normal distribution, a rough drawing. You don't have to have an accurate drawing. So if we could say, here's the normal curve, and as you know, the middle line here would be the mean. And the mean here, we have mean to be equal to 5. And now what we're trying to find, we're trying to find the percentage of the data above 3. So 3, it's going to be here before 5. So this is about 3. So what we're trying to do is to find the percentage of data located on this side. The first thing you need to do is to calculate the z-score. The z-score is equal to x minus the mu, the average, the mean, divided by the standard deviation. In order to do this, implement the x to be 3 minus 5, divided that by the standard deviation of 2. And that would be equal to minus 1, negative 1. Okay, so now we have the z-score to be negative 1. What would be the next step? The next step would be going to the appendix, the z table, and this could be found by the end of the textbook, or you could find it anywhere online. Just Google the z table. So now the z-score, we have it to be negative 1. So in appendix 1 on the textbook, which you see it now in front of you here on the screen, go down to minus 1.00. So now minus 1.00, that would be the one on the left, far left column. So the number would be this one, 0.1587. So take this down, 0.1587. Now let's go back to the question. So now what is this value? This value basically will tell you the area under the score 3. Therefore, we don't need this. We all need this one. Since we know the whole thing is 100% or 1, and we know this small area right here to be 0.1587, so the area on the right side would be equal, the percentage would be equal 1 minus 0.1587. And this should give you 84.13%. So the percentage of the data located on the right side of 3 or above 3 would be 84.13%. So I hope this is helpful. So let's take another example. Let's remove all this, erase everything here. And we'll move on to the next example. The next example is a normal distribution of test score has a mean of 38, so the mean is 38. The standard deviation is 6. what percentage of the students scored between 30 and 45. Okay. First step, what you need to do is to create a rough draft of the normal distribution. The mean is in the middle. And the mean we know from the question to be 38. What we're trying to find, to find the percentage between 30 and 45. We know the 30 would come before the 38. So this is the 30. 45 would come after the 38. So this is 45. So what we're trying to do, we're trying to know what would be this area right here. Again, this is a rough draft of the normal curve just to give you an idea on what we're looking for. And now we need to find the z-score for both of them. So the z-score for the first one would be 30 minus the mean, which is 38, divided by the standard deviation of 6. So the z in this case would be a negative of 133. 133. Let's find, based on the 133, what would be the percentage. P is equal, based on the z table. Go to the z table. 1.33. Here's 1.3, and we're going to have 0.3, which is 1, 2, 3, 4, the fourth column from the right. So the value is 0.918. 0.918. I'm going to put this one down. 0.0918. 0.0918. Okay, we'll take this back to the question. Okay, the P would be equal to 0.0918. Now, next, let's do the other value, which is 45. Z equal 45 minus 38, the mean, divided by the standard deviation of 6. And that would give you a Z equal to positive 1.16 or 7, 1.6 or 1.17. Now let's find the P. What would be the P value for this Z score? Go back to the Z table. And we're going to the positive values. Positive value would be 1.1. So 1.1 here, we found this. Now 1.17, 1.17, which would be right here, 1.17, 1.17, and 7 would be the third column from the right. So 1.1, it would be this value, 8790. 8790. Okay, let's put this one back on the answer. So that would be 0.8790. Okay, now we found the percentage for both values. Now, how are we going to handle this? Now, what is the percentage of the first one, the 0.0918? That means this is the portion below the 30. So this is the one. So from here to here would be 9.18% of the normal curve or of the data. And the other value that we got, 8790, would be the percentage of the normal curve from here all the way to the left side, and that would be about 87%, 0.9. 87.9%. In order to find what would be between them, subtract both from each other. That would give you a portion of 87.9 minus 9.18%. If you use the calculator, (87.9) minus 9.18, that would give you a 78.9%. 78.72. 78.72. 78.72% of the data located between these two. Now, what we need to do, we need to double check our answers, okay? And sometimes you don't have time to do all this math. So I did included a link for you on D2L on this PowerPoint, and this is basically a quick way to calculate the area under the curve. So if you open that link, and let's apply the first example. The first example we have is to be mean of 5, standard deviation of 2, mean of 5, standard deviation of 2, and we're trying to find out the area above 3. So above 3. And the nice thing about this, it's kind of a simulation where you see the shape of the normal curve. And here what we have 5, the mean, 2 is the standard deviation, and we're trying to find the area above the 3, the score 3, and this will give you the area to be, or the probability to be 84.13. 84.13 is this area right here. Okay, let's apply, let's use this website to solve the other question. The other question we have mean of 38, so let's change the mean to 38, and standard deviation of 6, and we're trying to find the percentage between 30 and 45. So select between, and that would be 30 and 45 and 45. Okay, again, that would be look into the nice chart that we created here. It's a great demonstration for the concept. As I mentioned, sometimes we need to simplify things by drawing the normal curve. But in this, if you use this one, especially if you have a quiz and you don't have that much time, you probably want to use this resource. But it is really important to know about the normal curve and why we use the normal curve in quality, because we need to see abnormalities in our data. As long as you remove the variation from the process, you will improve the quality of your process. So how you could remove the variation? By studying the data itself. You need to make sure the data can fit under the normal curve and see if it's normally distributed or not. If not normally distributed, then we have to find the cause of the problem, and we have to apply the 7 quality tools. We can apply the 6 Sigma methodology, etc. But this is essentially, this is a really important tool to help you improve the quality. And the first step to improve the quality is to study the data you have. And then once you study the data and see if it's normal or not normal, then you could make decisions based if you need to improve the process, if you need to improve the quality. And this is a really important concept in quality assurance. You should be able to do the calculation by yourself. However, there are other technologies such as this website, such as Minitab, another software that we will learn. It will help you to find out what would be the percentage, the area under the curve, etc. But again, this is really important. I hope this is helpful. Please let me know if you have any questions. Thank you.